Hi guys, welcome to the fifth episode on trying to get Dogen to move over to GitHub CI instead of Travis in Appware. So I had to do a little bit of work without recording. Double check we're recording, to be honest. Yeah, looks like we are. Because I needed to catch up with vcpkg, and it takes a while in terms of reading, try to understand what's going on. Let me just swap my monitors. Sadly, for recording purposes, it's easier to make my secondary monitor the main one, just to do this new setup we got here. So yeah, after a bit of faffing, we managed. Oh, in fact, to be honest, I think I just flipped it the wrong way around. Let's try again. Right, so that is actually how it should have been in the first place. So with a bit of faffing around, just double check that we're in the right place. Yeah. Bit of faffing around, we managed to get vcpkg. Well, we managed to move to the latest vcpkg support. So we did have vcpkg before, but like I said, there was quite a few problems with the way we had vcpkg in MASD in Dogen. One of the problems was that we had a fork, which is still available, of vcpkg on our own repo. And the reason why we had that fork was because we had packages that were specific to Dogen that were not in mainline vcpkg, mainly ODB. So we went through all of the packages that we had and figured out that actually the main ones were ODB and Boost DI. We didn't really need that much, really. So we just got rid of all of those packages so that we could use mainline vcpkg. That was done, and then after that, I just had a quick look at what's the sort of the way the cool kids are doing vcpkg. It's a bit difficult to do the reading whilst recording, so I just did that offline. So it seems like the theory is to create a submodule, which we did. The submodule is done. Actually, I wonder how. One is to add submodules in terms of staging, but the submodules are point to whatever commit you are in vcpkg. We did that, and then we created a vcpkg.json file that just states all the dependencies that we've got in vcpkg. That seems simple enough. Once that was done, we just had to add a couple of incantations in CMake, and that was about it, really. There's not a lot to it. We working on these two things. So literally, these 4 files here was the sum total of all the changes that were needed in order to support vcpkg properly, rather than the way we're doing it. Once we've done that, it was a very long build because, of course, it had to build Boost and all sorts of other things. It went away, did the build, and well, it just worked. So this is really good. To be fair, we are building with GCC 11. For good measure, while we're talking, I'm just going to try to see what happens if I try Clang. I'm pretty sure this is going to fail. Okay, right. So what happens is if you change the compiler, it re-downloads all of the dependencies again. Okay, let's just stop here for a second because we probably don't really want. Okay, that's fine. So the reason why, so this is just a peculiarity of the way things happen in vcpkg. So the reason why it's downloading all the dependencies again for a new compiler is because we have a different output directory per compiler. And the download directory and the install directory for vcpkg is, well, actually it's not obvious here, but I thought was inside the output directory. Let's see what happens if I go back to GCC. So if I just go back to GCC 11, yeah, so that's all kept as it was. I think it seems to me that we have 2 different vcpkg directories with all the files, and which is probably a good idea because it means we're going to compile all the downloads with Clang and with GCC separately, which I think is a good thing, just to make sure everything's clean. So I'll leave that running after I finish this video. So I'm kind of more or less happy that we have got a GCC VC package based build that seems to be working okay. And what we'll do now is we will commit all of this stuff. Presumably not much here, so let's just say VC package add support for, or add submodule for VC package. Okay, so now we've got a slightly more sensible implementation of VC package. I think we just need to start the CI work now. So what we'll do is with the CI work is we will, now that we've got the submodules, hopefully we can take okay, so we still have one thing we did not do, which is a CMake presets.json. Now I'm not sure what that means, but let's do a quick search for this file in case so here's an example of a CMake preset. Just some variables related to CMake. Not entirely sure the usefulness of this file. Okay, this is maybe useful because one thing we are doing at present, in fact, this is probably quite useful. I think sadly we might need to do some more reading offline. So the idea here seems to be to set up everything in a sensible way. So let's give you a bit more context. So the way we do things at the moment in terms of the building is we've got build Linux, I believe. Again, this is probably something historical, right? This build Linux thing, what it does is it does all sorts of things. It finds the compiler, exports all the variables to the compiler. It sets up the output directories using the compiler, and it defines a number of CMake variables, including the CMake tool chain file and things like that. Now, I think really this has been replaced in a way. The functionality that we are making use of has been more or less superseded by this CMake preset, I think. It would be nice to be able to move to this world where we're doing things in the standard way, because as you can see here, we have a lot of variables that are cached here. It would be nice to see an example of somebody making use of this file rather than just a documentation one. See what happens if I say GitHub. Okay, there's an example here for VS Code. Let's continue. I'm hoping that it's going to be a C. There we go. So this sounds a bit better. So this is a proper C++ project, hopefully. Yes, and hopefully we'll be able to see how they're using it. So as you can see here, they have a number of configurations, I guess you could say, which has all the variables that we need. Yeah, I think we need to use this file. So one thing I wonder is how does CMake make use of this file? How do we let's just read this a little bit slowly. So one problem is sharing. This may then CI builds user for CMake supports two main files. Okay, so these are the two files that we're talking about. CMake leaving the roots directory. Both have exactly the same format. The make tag being control. The question that I don't see an answer for is how do we then choose one of these configurations? So this is all very nice, but some of the problems with the documentation is sometimes you just need some kind of very straightforward example when you haven't got a lot of time, as we don't. We need just a very simple example of how to make use of these things. I assume that the GitHub workflow is going to have some reference to the CMake presets. I think it was GitHub CI. No, they don't use GitHub. Okay, cool. Let's see if we can find one of the GitHub CIs. No example. Ah, yeah, bingo. Right. Yes, okay, bingo. This is exactly what we want. So all the stuff that we had hacks for are now very nicely addressed. It is a shame we don't have a proper example of how to do this CMake preset, because whilst this guy here is giving us a really good example, it's not making use of the CI, the GitHub CI, so it's not linking in completely. I'm sure there'll be another one somewhere. Just need to find somebody that is making use of the GitHub workflow. Here we are. GitLab. No, somebody must be making use of a GitHub workflows. Okay, so build, test, Ubuntu, Windows. Let's start with the first one, I guess. Build and test. Windows, Ubuntu. Okay. Some secrets. vcpkg show. No mention of we expected to see some kind of mention of the presets. It should be slightly more obvious, shouldn't it, really? Let's just do a generic search for CMake presets. I wonder if CMake presets has some kind of aha, here we are. So we just need to supply the preset. Okay, so that doesn't look too bad, really. We just need to supply the presets, and a bit of luck. One thing that would be nice, though, in the preset would be to say compiler name. So we have a host. See if it's possible to select a compiler. So if we just say CMake preset compiler, it must be a variable for the compiler as well. Let's go back to the documents. Environment. Presumably CXX with the compiler. CMake the compiler. Okay. CMake presets in practice. This could be it. Okay, lots of documentation, but sadly we just needed a slightly more example-based approach, really. KDAP tends to come up with really good examples. Let's have a look. Really good work, in fact, in general. Nope, not this time. Right, I think we're gonna probably have to do some investigation before we can proceed. I think we need to understand a bit better what is going on in terms of CMake presets. I mean, what we're trying to do is very simple, really. We just need to create, if you're looking back, we just need to create the configuration on the CMake presets, which is probably quite simple. We can take one of these examples and copy and paste. We need to take the variables that we got all scattered around our build files, which will probably become redundant after this. I can delete all of these guys. We take these variables and we can put those in the presets, and then we probably just need to call CMake with ---- preset, and I think that will do the job. The only thing I think that will be a slight problem is that the configuration doesn't seem to have a variable for the compiler. We need some kind of way of saying that oh, unless actually there is another option, which is we just default to whatever the compiler is, and then the preset name is the compiler name. In which case, we'll make it quite straightforward to do this. Yeah, perhaps this is it. Cached variables. I mean, there's a lot of information about all of this, but sadly, this is a bit too detailed. It's definitely too detailed to be able to do this in a video, because we need to actually read through this properly. The other interesting thing as well is where things like use Ninja and then debug build. It's not obvious how these things interact, because presumably one would want to make a debug build with Ninja. I'm not sure if there's some kind of inheritance. Yeah, presumably this must be inheritable. Ah, here we go, bingo. So there's some kind of inheritance that enables you to then say this thing is a sum of all of these other options, and finally we create the build preset that matches the configuration preset. Okay, cool. I think we kind of got the gist of it. It's not going to be possible to do all of this in a video, so what we're probably going to do is I'm just going to pause for a little bit and then resume once I got my head around the basics. I think we just need to read up on the documentation for 10-15 minutes, and then I'll resume the video. So I'll just pause this for a second. Okay, that was a quick read. Double check we're recording. We are recording. Really, the gist of it seems to be this chap's here, Nick, seem to have done a good job. We're just going to go with their approach. Largely seems to be similar to what we need. So let's just have a look at what they've got here and then diff that side by side with ours. I think we've more or less got the same requirements, really. So export compile command sounds sensible. Default build dir source directory builds. I think we need to change that to become something like build output, I believe. Yep. So we'll just call that build output preset name. Then I think we can stick to these debug builds. Not sure what hidden means. That looks fine. Release with debug build. Well, I think fine. We can take all of these. Then use Clang. Well, looks very sensible as well. Use GCC. Presumably, that's going to be very similar. MSVCCL. Okay, and then MSVC Clang CL as well. And now we have Linux Clang debug, Linux Clang release. So all the way up to here is making sense. Windows Arch 64, x64. Not too sure what this stands for, but let's have a quick look at this. So some Windows specific options, presumably. Windows default, Windows debug, Windows release. Now we enter the CI options, build testing, demo view. We don't really have these options, so these are definitely not going to be necessary, but let's just keep going. Right, so then we install additional library paths. This is presumably where vcpkg is going to install stuff. And some coverage here. Okay, so I think, to be honest, I think we can probably get away, at least with a starting point, we can get away with exactly their presets. I'm not even going to make any changes to this. The only thing I'd like to do, I mean, of course, as you can see, we have a lot of other things in our on our options that we don't seem to have available here. So, for instance, we definitely want to put latex off. We don't want latex to be generated. See where they put their options. Debug build, release build. I think what I'm going to do is I'm going to just create sort of a hand version of these. Right, so these guys here, it's not necessarily the case that we know what we're doing right now, but we just need a starting point really. So if we just basically say something like this, and now we will copy across whatever needs. Build child lives off. I mean, I'm actually, some of these things I'm not going to copy and paste because I wonder if I wonder what they're used for. So for example, with full generation, not too sure what that means. With full generation, some of these things could potentially have bit rotted over time. It is possible that we've got things here that we don't even use anymore. So full generation, generate. Okay, right, yes. So we don't really want this. This is some kind of test that we had before. So this presumably is going to be off. No, it's actually on. Well, fine. If we simply believe on is a good value, let's leave it on. For now, at any rate. Oxygen, debug and release, coverage. Right, our nightly build is also struggling a little bit at the moment. We haven't actually managed to get anything building for a while, so part of our bit rotting, I guess. Should have been a sticker here, a badge for CMake. C dash, there it is. So that's our C dash dashboard. The good news is we seem to be building. So that's good. We are failing a lot. But that's fine. We know exactly what's going on here. If you look here before, we were not even building, so things are going in the right direction. we seem to be increasing the defect count and val grind. So what we need to do, I think, is double check. These are probably related to the version of CMake that we're using, I guess, or the version of Boost. Yeah, exactly. Okay, so that's fine. That's not a problem. Just the version of Boost. We can just point to the latest CMake. That's an easy thing to change. However, all this to say, profiling is important. So we need some kind of way of saying we need coverage. So well, let's just not get confused with too many problems at the same time. So we'll leave these guys for the moment. We don't really know exactly what he's doing there. I think all of these guys are going to be very similar. And so we'll leave that as is. So what we're really trying to answer, the question we're trying to answer is, can we build it all at present? So we have a lot of presets here. What would happen if we tried to do a Linux GCC debug build? That's the question, I guess. Let's just get a shell. And, well, that's a good question, actually. Not quite obvious where the builds, where CMake should be called from. Let's just call it from here, see what happens. Okay, something is happening. Now, whilst something is happening here, we shall have a quick look. Right, so debug build using GCC. Now, what I'd like to see is what exactly is this thing doing? Output. Okay, that's good. That's excellent. So the only slight downside, as you can see, this thing seems to be re-downloading and reinstalling all of Boost again, which is annoying but understandable because we changed output directories. So that's bound to happen, right? Seems slightly faster, actually. What's not obvious is... Okay, not too bad. So I guess we just need to say minus build, presumably, to ensure this builds. Okay, cool, excellent. So that was remarkably a success. Right, so let's just do a slight change here. So CMake minus version. It's going to be a very old version. Okay. Right, so I thought this was going to be quite old. It's actually not that bad. So we have a local version of CMake. A little bit more recent. So why is it that the current version of CMake does not like Boost? It's surprising. It's going quite well, actually. It's a bit surprising, but it's a bit annoying though that we're still having a couple of problems with things like Boost. So the problem with Boost seems to be that the version of Boost that we got in vcpkg is more recent than the one supported in CMake. One way to solve that problem is to use the hand-picked version of Boost that I got, of CMake, sorry, that I got here. And this version should, in theory, support latest Boost. So I'm just going to do a quick hack here. I'm going to run the exact same command we did 5 seconds ago, but with my own special CMake. It's already building, so I wonder if I could just force it to... Right, here we are. This is slightly better. Yeah, that's not too bad, really. So the general conclusion is that preset seems to work very well. We probably just want to do a little tiny cleanup, very, very small, which is to get rid of all these variables we're not making use of. In fact, to be honest, we probably don't even need to do that, which is quite nice. So that is it. Actually, it's surprisingly enough that has worked quite well. So I'm just gonna go over to my compilation window. Now, as you can see, our typical compilation is a little bit more involved than that. So we have a few variables that we supply. These variables are related to the location of the test data that we use to run the tests. Ideally, we really want to move over to using the presets for them as well, so that you can, well, so that things just work out of the box. And the best way to ensure that is to make sure that we are always relative to the directory where the source code is, so that I don't even need to hard code that really. I could just say go up a few levels from the build directory, from the source directory even, and then you will find the test data, which then will take care of, let's see, 1, 2, 3, 4 of these variables. Then we have the path to CMake, which we've already seen, and then finally the build script, which is us. Now, we don't seem to. One thing we are not doing at the moment is we're not setting the number of cores to use, which our script does. So that's one thing. But other than that, I think we can put everything inside of the CMake script. So let's just do that then. Before we go any further, let's just go back to this chap here, and let's then say Dogen common options, cached variables. So we need something slightly different, some environment variables perhaps. Let's just drop these guys here for a second and let's think. CMake presets perhaps. Environment. There must be some kind of way of setting the environment variables. Right, there we go, bingo. So presumably one can just declare an environment inside of the configure presets. Alright, okay, cool. So I'm just going to attempt to declare an environment here. And the environment variables are going to be as follows. I'm going to say the convention we have is that the directories will always be source directory, which is a misnomer because it's actually the checkout directory, really. But it's fine, we'll accept that. So if you take the source directory, and then from the source directory, which in this case will take us to MASD, we would have to go one up. So where are we then? Integration. So that will take us to Dogen. So probably two up, I suspect. And then we are in the place where the test data is. So if I just say, I mean, this is obviously not the end all be all solution to solve all problems, but we just need to move from here to somewhere slightly better. I think this hopefully will give us that. So grab all of these guys and we don't particularly care about any of that, so for now I'm just gonna grab these guys as is. You have to remember that also that Dogen is a fairly old project. We were using originally very old versions of CMake. So there's a lot of functionality, a lot of nice things that have been developed in CMake since we started. We're quite behind really, because our focus has been on the thesis rather than engineering. So this is really a time to catch up with all these technological changes. Finally the path, we don't care about that. Then the build script, and now I think we just need to worry about how many cores. Now for that, we're just going to leave that as is for the moment. So the Dogen common options will supply us with all of these directories, and then if we just basically say that I wonder if it's not easy to just say that all of these guys here are going to inherit. I mean, like I said, this is not going to be the best solution we possibly could imagine. We just need something that kind of works, because once it's kind of working, then you can easily make it better. So this is the first attempt at something that compiles and vaguely resembles the current setup. It will not be perfect, but that's not too important. So, excuse me, bit of a cough attack. So what we'll do is we'll see what happens if we try to run from the shell. I'm just going to do a clear one. So that what we want to do is we want to see. Okay, that was presumably quite successful. So it's very surprising how well this is going. Yeah, that actually works. So now we have the environment variables being set. We've got, well, we have a couple of things. To be fair, let's just get rid of a few things we know for sure we don't need. So I'm not sure what use debug output does, but I do know that we had something else. We had profiling on and off. Yeah, I'm not too sure this use debug output. I think these are probably specific variables that they are designed for the other project that we copied and pasted from, rather than our project. Just to double check that, what we can do is you can just quite quickly go up to whatever we got that from, these guys here, and if we just open up that CMake file and do quick, yeah, here we go. So as you can see here, there's a number of variables that they've set up for their own purposes that we don't really know. They don't really have a meaning in Dogen. So our best bet is to try to tidy these up before they become embedded in our scripts and we don't know what they do anymore. So these are not actually going to be very useful for us. Other than that, I think we succeeded. Let's have a quick look at the output. So the tests seem to have gone through. As you can see here, we picked up all of the directories. vcpkg install seems happy enough, interestingly enough. And away it goes. So in theory, and I mean very much in theory, we can replace our compilation command now with something like this: cd over to our directory where the CMake file is, and then run CMake, say for Linux debug. But then of course we have to remember that we're now using proper CMake commands, so tell it to build. Right, so now what this should have done, hopefully, is it should have picked up all of the information that we got from CMake, the presets, does the build, points to the vcpkg directory, which is nice, and then uses all of those dependencies. And the only thing I think we're not doing, presumably, is we're not really using many cores. So let's just leave that running. No point to stopping that. Let's try to understand how we have more cores. I think there's a Ninja. Yes, Ninja minus J. Okay, so what we need to understand then is how does Ninja determine how many cores to use? Presumably jobs. Right, let's just do a quick search here and say CMake presets Ninja jobs. We just need to figure out how do we say Ninja please use X amount of jobs. not entirely clear how many ninjas we're running at the moment, to be fair. Let's just double check that we are not using 6 cores. I mean, I don't know why we would, but let's have a look. Seems like we're using 2. 1 even. So CMake resets jobs, maybe. CMake jobs. Alright, okay, here we go. So now we know, of course, that this is going to basically say oh, wrong button. Ah, here we are. Minus parallel. Excellent. So we have minus parallel and we have minus j. Okay, that's excellent. So let's now say, please stop at some point. You will listen to us. Well, taking its time. So let's say, please give us this with 6 cores. Probably could do it more than 6 cores, but right. So this seems like we've. In fact, this seems to be going slower now. Interestingly. I was expecting for it to go faster rather than slower. Well, at least you could see 1, 2, 3, 4, 5. You could see 5 of them being generated simultaneously. What does the shell say, I wonder? Still a single ninja. What about GCCs? Ah, okay, excellent. Perhaps we should have queried the number of GCCs rather than the number of ninjas a second ago. So just to be on the safe side, let's just stop this for a second. Let's take away the j. Start again. Now this is without supplying any variable. Presumably we expect to see, well, interestingly enough, we're seeing much more than 1. So actually, as it turns out, the default parallel is probably equal to the number of cores by default, interestingly enough. We have also a number of things here that we got historically. We probably shouldn't really be doing these things now, because this has been here for ages. Who knows what that does these days. Okay, so fine. So actually, as it turns out, it seems that it's sensible to just use the default rather than try to override the defaults. Okay, that's very good. So at this point in time, we seem to be able to build with presets. So we just will make sure that the tests are also running correctly. That will be slightly harder, I think. And while we wait for that, let's just add a link to our new playlist on the make file, on the README. Sorry. This is all channel stuff. Yes, this is the playlist, I believe. So while we wait, we will just update this chap here. So MASD, Dogen encoding. So this is the new playlist. Oh. And you will just the reference here. And these are a series of videos. What I'll do is I'll just quickly, this is a bit meta, seeing the video being playing on the video. But what we need to do is just make sure the description here matches. And that should do the trick. We're still building as it stands, so no rush there. Let's just say README, add link to new playlist on GitHub CI. Okay, so that's kept us busy for a few minutes while we're waiting for our chapter to finish. I think I'm happy enough with the presets. I'm just going to say CMake add presets file file copied from project. We always try to source things correctly for two reasons, really. The first thing is give credit where credit is due. Sometimes, like JSON, for example, can't actually put the copyright notices and things like that. So we need to somehow keep track of where we got things from, so that if somebody comes back and says, well, you haven't got the rights to use that, we can easily figure out what's the blast radius and remove things accordingly. But the other thing as well is that in a few months' time, when we look back at whatever work we've done here, we may need to update the file, for example. We need to figure out where the file came from and so on. And it's always nice to be able to see the history of the file and see, oh, yes, we got this from XYZ, making our life much easier. Right, so what we need to do then is we are on the linking stage at the moment with our presets build. I must say I'm slightly surprised this is going so well. Not normal with C++. I was expecting a lot of problems. I presume that what's going to happen now is probably that the tests are going to fail or something silly like that, and then we will spend about 2 or 3 days trying to figure out what's going on. It's not normal for these things to go so well. We're not even an hour into it. Linking is a bit slow. The other thing as well, of course, is we are still using the LD, not gold, the linker. So there's some more work to be done there. But if we look at a tick list of things that our friend Luca asked us to do, we are more or less at the end of the things we needed. So we've done the submodule, we've done the JSON file. We haven't quite read through this properly yet, but there was one more thing, which was the presets. There we are, the presets. And then, presumably the last step really is to, well, to create the workflow, I guess. It's quite exciting. I think we could probably just copy and paste this from here. Interestingly enough, this is still, well, not sure what this is doing, but still going. Never seen a compilation take this long, must say. Let's have a quick look at what the processes look like. Not much happening. This was going too well, I think. Not obvious what this thing's doing at present. In fact, it doesn't look like it's doing very much. Okay. I assume this is where things are going to start to go wrong. Of course, we don't necessarily need to go via CMake. I mean, I prefer to go via CMake, to be fair, but we don't necessarily need to. We could go straight into Ninja. I mean, it's very worrying that we don't see any references here to Ninja. Oh, it is actually there somewhere. I wonder what Ninja's doing. I'm just going to kill this chap for a second. It's interesting that things were going so well, and now suddenly we seem to be stalling. For no good reason, really, because it doesn't seem like it's telling us what's going on. Right, okay, so hopefully... Okay, excellent. So at least this compilation finished. So now what we're going to do is we are just going to go into our build outputs Linux GCC debug directory, and in here, I'm just going to run Ninja for a laugh. Right, as you can see, Ninja is the one that's stuck. So let's just kill Ninja. Yeah, so Ninja seems to be what's causing the problem. I'm going to open up a regular shell. This is me doing some experiments somewhere else. So we don't need that. So if we just go back to MASD and Dogen, I find that for whatever reason eShell sometimes is a little bit unresponsive when it comes to Control-C. I'm not sure why, but let's just get rid of this Ninja for a second. And as you can see, we're still kind of going here. Let's give it a bit of a bigger impetus to leave. Okay, here we are. Now, why is Ninja not doing anything? Is that Ninja minus verbose? Must say, Ninja is behaving a bit strangely. Just going to run Ninja from, instead of eShell, I'm going to run it from here. I mean, I don't think eShell is causing the problem, to be fair, but sometimes you just need a regular shell. Right, you can see the problem is Ninja. So let's see what Ninja is trying to do. That was correct. It was supposed to be verbose. Nothing happened with verbose. What's debug? Yeah, it's not obvious. Ninja is getting a little bit confused. Seems like it's computing something. Not obvious what exactly it is computing. But it's big because it's taking forever, and this is a very beefy machine, so one would have thought whatever it is that it's doing, it would do it quickly. OBS, presumably. Oh, okay. So I'm using our CPU, not the top. Interesting. It's slightly puzzling now because we don't really know what Ninja is doing and why it's not coming back to us. Verbose is not helping. So I shouldn't really have said that things were going too well. It's always the way. As soon as you say that, something bad happens. And this is actually pretty annoying because we've had cases where we ended up having to stop using Ninja for really strange reasons. We couldn't quite figure out why Ninja stopped working. And then we are forced to move back to Make, which is not a big problem, but I mean, never good to regress slightly. Right, so Ninja thinks it's just doing some linking. That doesn't seem too bad. Perhaps we just got unlucky. Let's just bring this down to lack of luck, and I think Ninja is trying to link. Let's just make sure that we're not doing something silly at the linking stage. let's make sure we're not doing anything silly at the linking stage. Let's also link one at a time. So if I just say ninja manager 1, for example, does that change things slightly? As you can see here, although there's a lot of LD stuff coming through, not exactly what we're looking for. I was expecting to see just the linker, but so Spotify, all sorts of stuff. Okay, well, I think given that we are close to an hour, I'm trying to stick to a duration of about an hour in these videos. So the problem we have, which will probably require a little bit of thinking now, probably just a bit of time wasting really. For whatever reason, Ninja does not seem to be very happy when it comes to linking. Before I do anything else, I'm just going to go back to using gold, because this is probably trying to default back to LD. I will also try to use Make instead of Ninja to see if it makes any difference, because this doesn't really make huge amounts of difference for the purposes of what we're trying to do. If we have to go back to Ninja, we'll go back to Ninja. That's okay. To Make, that's fine. What we really don't want to do is to block everything else on the back of this. So we'll just do a bit of investigation in the background, and then for the next video, we'll explain how we solve this problem. Thanks for watching.